So, Mantrika, in this lecture, we'll be understanding this table. All sine, tan, cos. Do we understand this well?
Yeah.
So, the mnemonic can be after school to college, or it can be add sugar to coffee, or it can be all science teachers are crazy. So using this mnemonic devices, we understand that how do the signs of the how do the signs of various trigonometric functions vary. So
Mm.
here sine, cos, tan and their reciprocals are positive. Here only sine and its reciprocal cosecant is positive. Here only tan and cot is positive on the
Mm-hmm.
Hmm. Okay. All sine, tan,
Yes.
cos and secant. So here everybody is positive. Everybody
Mm-hmm.
is positive. Here only sine and cosecant are positive. Here only tan and cot are positive. Here only cos and secant are positive.
Yeah.
So if sine now it goes without saying that if only sine and cosecant are positive, then rest of the people that cos, secant, cot, tan, all of
Yeah.
them are negative.
Yeah.
Are you clear about this, Avantika?
Yes.
Okay. So this is the first thing that we need to understand, and that is why
Mm-hmm.
we did a small revision. That
Mm-hmm.
in the first quadrant, these people are positive, and second, these are positive, and in the third quadrant, these are positive,
Mm-hmm.
and in the fourth quadrant, these are positive. Are we clear till
Yeah.
here?
Yeah.
Okay. The second thing that we need to remember is the second thing that we need to remember so that we understand the trick well is that this is 0, this is 90, this
Mm-hmm.
is 180, this is
Mm-hmm.
270.
Mm-hmm.
Theta would always be acute. Theta is always acute.
Yeah.
Okay. So this would be my theta.
Okay.
If I do a 90 minus theta, the 9 because theta is acute, 90 minus theta will always be acute. Have you understood what I said?
Yeah.
So for example, if theta is 30 degrees, 90 minus 30, 60 degrees would always be in first quadrant.
Yeah.
So 90 minus theta would always lie in the first quadrant. Are we clear till here?
Yeah.
Similarly, 90 plus theta would always be in second quadrant. Are we clear till here?
Yeah.
Similarly, 180 minus theta would always be in second quadrant. Are we clear?
Yeah.
Because again, if theta is 60 degrees, then 180 minus 60 is 120 degree, 120 degrees in the second quadrant.
Yeah.
Similarly, 180 plus theta
Hmm.
and 270 minus theta
That's
would
theta.
always be in the third quadrant.
Third quadrant. Yeah.
And 270 plus theta and 360 minus theta would be in the fourth quadrant.
Fourth quadrant. Yeah.
Actually, 360 plus theta would also always be in the first quadrant.
Yeah.
Are we clear till here?
Yeah.
So we have we have theta, we have 90 minus theta, we have 90 plus theta, we have 180 minus theta, we have
Hmm.
180 plus theta, we have 270 minus theta, we have 270 plus theta, we have 360 minus theta. As
Yeah.
a part of it, I can also write minus theta here. Are we clear till here?
Yeah.
Okay. Now, why I wanted to show you this was because when I construct my allied angles table, I
Hmm.
can write the values like this: minus theta, 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 270 minus theta, 270 plus theta, 360 minus theta. So I can construct my table like this.
Hmm.
So now compare this table with the
Hmm.
table that we had started with,
Hmm.
this table.
Yeah, yeah.
So if you see, one thing, just give me a second here. Just give me 1 second.
Yeah.
So now, when we again look at this table, let us make sense of this table again. So when you look at minus theta, you know you are in the fourth quadrant.
Yeah.
When you look at 90 minus theta, you know you are in the first quadrant.
Quadrant.
When you look at 90 plus theta, you know you are in
Second
the second quadrant. 180 minus theta, second quadrant.
quadrant.
180 plus theta, third quadrant.
Third
270
quadrant.
minus theta, third quadrant. 270 plus theta, fourth quadrant.
Fourth quadrant.
360 minus
360
theta,
minus 6.
fourth quadrant.
Fourth.
360 plus theta is first quadrant. Is
First
it?
quadrant. Yeah.
So there is some semblance of, some sanity now
Hmm.
that, slowly we are understanding how the table works. Okay.
Hmm.
Now is the most simplest thing that now there are, two ways in which you can remember. The first way of remembering the values is that, for example, you have sine, you have, say, okay, let us say you are asked what is sine 180 minus theta, or you are asked what is sine 180 plus theta, or you are asked what is cos 180 minus theta, or you
Hmm.
are asked what is cos 180 plus theta.
Yeah.
Okay. Now, this is the first question which is asked.
Hmm.
These are the four values they asked in the first question. In the second question, they ask you values like what is the value of sine 90 minus theta? What is the value of sine 90 plus theta?
Hmm.
What is the value of cos 90 minus theta?
Hmm.
Uh, what is the value of cos 90 plus theta? Yeah. Okay. So let us look at the simple one first. So sine 180 minus theta. Whenever they asked you anything regarding these values, say 0 minus theta,
Hmm.
or 0 plus theta, or 180 minus theta, or 180 plus theta, or 360 minus theta, or 360 plus theta.
Hmm.
Whenever whenever these kind of identities are asked, say for sine, cos, tan, it hardly matters. Cosecant, secant, cot, it hardly matters.
Hmm.
Whenever they'll ask you what is sine 0 minus theta, what you need to remember is that sine would remain the sine on the right hand side. But depending upon which quadrant you are, so for example, sine minus theta, you are in the fourth quadrant. So the value of sine in the fourth quadrant is negative. That is why this would be negative. Does it make any
Okay.
sense?
Yeah, yeah.
I'll be taking a lot of examples, don't worry.
Hmm.
So sine 180 minus theta, sine 180 minus theta.
Hmm.
Because it is 180, sine would remain sine.
Yeah.
180 minus theta, 180 minus theta is in the second quadrant. In
Second
second
quadrant.
quadrant, sine is positive. Therefore,
Positive.
this would be positive of sine
Positive.
theta.
There.
Any doubt?
No.
Cos 180 plus theta. Because it is 180, cos would remain cos.
Hmm.
But cos 180 plus theta, in which quadrant does 180 plus theta fall? 1, 2, 3.
Third, third.
All sine tan. Cos is negative, therefore this.
Negative. Okay.
Tan 360 minus theta, because it is one of the values 0, 180, 360. Whenever
Hmm.
you will see 0 plus minus theta or 180 plus minus theta or 360 plus minus theta,
Hmm.
whatever is the function on the left hand side, the function would be the same on the right hand side. Don't worry about the function. Just worry about the sign of the function. So what this implies is that tan 360 minus theta, tan would remain tan.
Hmm. But negative.
360 minus theta, all sine tan cos. We are in the fourth quadrant,
Fourth
all
quadrant.
sine tan cos. But this is negative. Any
Negative.
doubt? Any doubt?
No. No.
So whenever the values are 0 plus minus theta,
Hmm.
180 plus minus theta, 360 plus minus theta. So sine would remain sine, cos would remain cos, tan would remain tan.
Hmm.
And they are reciprocals.
Okay.
That is, cosecant would remain cosecant, secant would remain secant, cosecant would remain cosecant. So for example, cosecant 180 minus theta. Cosecant would remain cosecant because there is a 180 degree. So
Hmm.
secant theta. I need to worry about the sign. But where is 180 minus theta? 180 minus theta is in the second quadrant.
Second
All
side.
sign. Cosecant is positive. So this would be positive cosecant theta. Any doubt till here?
No.
Okay. Now let us look at the other values. When we face 90 plus minus theta or 270 plus minus theta,
Hmm.
sine will change into cos, cos will change into sine, and tan will change into cot, and cot will change into tan. Any doubt there?
No.
Okay, let us take few examples and try to understand. So for example, I have sine. Of course, they will change, but the second principle that we use of sine, the sine will be given by all sine tan cos only. All sine tan cos only. Let me show you with this example. So for example, sine 90 plus theta. Tan 90, tan 270 minus theta. Cos 90 minus theta.
Hmm.
Cos 270 plus theta. I will just add here that cosecant will change into secant and secant will change into cosecant. Okay, let us take examples. So sine 90 plus theta. Sine, because there is a 90 here, sine will change into cos theta. 90
Hmm.
plus theta is in the second quadrant. In second quadrant, sine is positive.
Positive.
So this would remain as positive. Does it make sense?
Hmm. Yeah.
For sine, you always have to take the value of the function on the left hand side,
Hmm.
not on the function on the right hand side. This is a common confusion.
Okay.
Is it making sense?
Yeah.
Let us take more examples. Tan 270 minus theta. Because there is a 270 here, my tan will change into cot.
Out.
270 minus theta. I am in the all sine tan.
Third quadrant.
Third quadrant. In
Yeah.
third
So
quadrant,
tan.
tan is positive.
Yeah.
So this would be positive.
Okay. Yeah.
Let us take cosecant 270 plus theta.
Okay.
Cosecant 270 plus theta.
Fourth
Because
quadrant.
270, cosecant will change into secant.
Secant.
Cosecant 270 plus theta. I am in the
Fourth quadrant.
fourth quadrant. Fourth quadrant, cosecant is negative.
Negative.
So this would be minus secant theta. Is it making
Yeah.
sense?
Yeah.
Cos 90 minus theta. Because of 90, cos will change into sine.
Hmm.
90 minus theta. I am in the first
First.
quadrant. Why? Because my theta is an acute angle. That is why this will
Mm-hmm.
be given as plus sine theta. Is it
Plus.
making
Yeah.
so cos 270 plus theta. There is a 270 here, so my cos will change into sine.
Hmm. Fourth
270,
quadrant.
yeah, 270 plus theta. I'm in the fourth quadrant. All sine, tan,
Cos
cos.
is positive.
So this would be plus sine theta.
Okay. Yeah.
Does it is it making any sense now? So this is how you can remember. No change when crossing 0, pi or 2 pi. So for example, if you are crossing 0, pi, 0, pi or 2 pi,
Hmm.
so whenever the angles are, so for example, pi plus theta or pi minus theta, or whenever
Hmm.
the angles are 0 plus theta, 0 minus theta, or 2 pi plus theta, 2 pi minus theta. So
Mm-hmm.
there would be no change in the function. Sine would remain sine, cos would remain cos, tan would remain tan.
Okay.
But whenever you are changing into 90 or 270, so for example, 90
Hmm.
plus theta, 90 minus theta, 270 plus theta, 270 minus theta, then sine will change into cos, cos into sine, tan to
Mm-hmm.
cot, cot to tan, secant to
Okay.
cosecant, cosecant to secant. Isn't making sense?
Okay. Yeah.
And then you have to look at the function on the left hand side
Hmm.
and match it with the quadrant to find the sign which you should put on the right hand side. Is it making
Hmm.
sense?
Yeah.
So, for example, now let us try to see whether the table that we have drawn is it making sense or not.
Hmm.
So, so let us take any random value tan 360 minus theta. So tan 360 minus theta. So tan 360 minus theta.
Hmm.
There is a 360. So tan
Yeah.
would remain tan.
Tan.
360
Fourth
minus a
quadrant.
yeah 360 minus an acute angle. So
Hmm.
acute angle might be 30. So I am in the fourth quadrant.
Hmm.
All sine, tan, cos. Tan is negative.
Yeah.
So this would be negative. So this would be minus tan theta. So tan
Mm-hmm.
360 minus theta should be equal to minus tan theta. Is it making sense now?
Yeah.
Let us take another example. Cos 270 minus theta. So cos 270 minus theta. There is a
Hmm.
270. So cos will change into
Fine.
sin. 270 minus an acute angle. You will be in the
Uh,
third
third quadrant.
all sine tan.
Hmm.
So cos would be negative in the third quadrant. So this would be
Negative.
minus sin theta.
Okay. Yeah.
So this would be minus sin theta.
Yeah.
Any doubt?
No.
Let us take a few more examples. So for example, tan 270 plus theta.
Hmm. Okay. As it's 270 changes to cot and 270 plus theta lies in fourth quadrant and is negative.
Is it making sense?
Yeah.
So that is why you will see here. That is why you will see here minus cot theta here.
Yeah.
Any doubt?
No.
Now, the important thing to for you as a medical student is to understand how this table works. That you have understood.
Hmm.
Yeah.
Yeah.
But we need to we also need to understand how these identities work.
Yeah.
So that is why I am telling you that just use these identities
Hmm.
to calculate and verify the values of
Yeah.
these three rows:
Hmm. Hmm.
sine, cos, tan, for
Hmm.
all these values.
Yeah.
So that once you have practiced 27 times,
Hmm.
9 3 is 27, you will remember these six identities. Any doubt?
No.